Are we live? Hard to tell. Twitch doesn't want to connect. YouTube does want to connect, which means it appears that we might be live. Oh, we're so live. We are so live. Man, you know, I am doing a really bad job of streaming 6 days a week, aren't I? Kind of a dumb idiot. Oh well. Oh well. That is too bad. Okay, why is Twitch not starting? Huh? Okay, it just doesn't want to start. It really doesn't. I'll check in like half an hour or something. I don't know. I don't know. Okie dokie, okie dokie. I guess let's just get started with our actual work. Okie dokie. Okie, okie. So, what are we trying to get done today? Start actually implementing stuff. Okay, so I have my tests written, do I? Well, it appears that I do have my tests written. Okay, so we're just implementing. That should be fairly straightforward, I reckon. Okay. Where is it? I'm just gonna copy and paste this thing over because I'm kind of lazy. Oops, conversation service, conversation agent, model factory, prompts, tools. So I guess let's just get implementing. I don't really know what we need to do. I assume our API more or less is correct, right? So we can kind of just do whatever. Twitch still doesn't want to start. Ugh. Okay, that's really awkward. Oh well, that's annoying. Ay 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 ay. So let's clear all of this garbage out. And where do we want to start? Let's not start with the API. I don't want to start with the API. Let's start. I want to first see, what do I even have? Okay, conversation service, event, self queue, get. Event user, conversation output event, sick, based. Model factory, this is probably the easiest one to implement. Yep. And I guess, okay, so in this case, we're going to just make Gemini. It should be fairly straightforward. And then in KWArgs, user can also specify which version of Gemini they want to use. Okay. Okie dokie, okie dokie. Load up Google Gemini as a base chat model. LangChain. Bro, Twitch is still not starting. Why is it so quirky? Why? Oh, I hate this. Okay. Let's just have it like this. Create Gemini. Pip install Google LangChain GenAI. And then chain Google GenAI or chat Google generative AI. And import OS. Oh, import OS. KWArgs. Okay. Should be really simple. And yeah. I guess we just got this thing, right? I guess first we need to load the API key. So run import load.env. Okie dokie, and then load.env. Wait, does it work this way? And then if hold up. Let's okay. Let's say I have a factory class for face chat models. I'll go more than just Google Gemini. How do I implement the method for creating Google Gemini face chat model? That's static method. Static method is definitely a thing that I can do. Wait, what about also having the environment load API keys? You know, we're looking for low cortisol, not high cortisol. So we're just gonna keep it low energy, not stress too much about stuff. And yeah. So does this automatically load? Oh, so you just load it in application startup. Oh, I see. So, I did not know that you can do that. For load.m, just need to do it once on application startup. In this case, running name or something. You can access it anywhere. Okay, that's great then. Do we need static method? Or so this is like per instance of the class, right? Instead, what if we just get rid of init and then we just have this thing as like static? Or Gemini. It should be self.create Gemini, right? Wait, hold on. Or I guess create model. Yeah. Hold on. A separate name for the model. Names mapping to the correct functions to create an instance of that model. How do I implement this? What? How can I implement this with the creation methods being static? So where the frick does this even mean? Class method. LLM factory dot creators. What? So does this mean we can do like this? Why can we not do this? Because it's not defined yet. So then can we do like from future import annotations? Future import annotations. It doesn't appear to work. I might be stupid. Okay. I still don't know what a class method is. Receives class itself instead of an instance self. Okay. Instead of an instance self, it is declared with class method decorator. Instance method operates on specific object. Class method operates on class. Operates on the class and its class variables. Class level data. So basically, class just allows you to use this kind of stuff. I feel like this is just really fancy. Like, is this best practice for creating factories? Let's ask Claude. Claude is probably smarter. That's right, I said it. Claude is cooler than ChatGPT. ChatGPT. How should I give you a simple implementation of a factory class in Python? Follow best practices for implementing factories. Okay. Oh, I see. Dict type string. Create. So you want to register it first? Wait, are you? Oh, I see, I see. Open close principle. Oh, that's cool. Well, that is really cool. But what if it requires an API key? That's the real question. What if something requires an API key? Which I remote shape raise value error. Okay, well, I am not implementing that myself, so dependency injection. API config. Yeah, you know what, okay. So to build something factory is already implemented some library. I need an API key to initialize of this model of this class. So should I just make a mappings dictionary in my factory class? It's thinking. See, it says that, but I don't believe that it's true. Like, I just really don't believe it. not just classes. Yep. Okay, I don't want to like register it. Adapters. Okay, this is. I feel like it's a lot more confusing than it needs to be. But yeah, I guess this is something that works. No, I'm just gonna put it all in the class. It is what it is. It is what it is. So model mappings, and then static method, create Gemini. Yeah, I guess it's not self, right? Because we don't take an instance of self, much like how here we also don't need self, so add class method. And we also don't need self here, I believe. So we just take class, model name, and also kwargs. Okie dokie. Create Gemini. So then how do you call this specific thing? Class dot underscore creators provider. Okay, so that's right. Okay. So what do we do if we don't have the API key? So API key which equals os.getEnv. Wait, what's the difference between os.getEnv and os.environ.get? Between os.getEnv and os.environ.get. Always safe to call. Never raising key error. Okay, so what's the difference? Full mapping object. And the full dictionary-like interface. Well, we don't need that. Get Google. If not API key, raise value error. Google. Raise value error. Try to load Gemini model without Google API key setting environment variables. And then do we need to get to that? And the kwargs. Do we need to pass in the API key? I assume so, right? Yeah. I'm just gonna ask Claude to initialize an instance of Google Gemini based chat model in LangChain. Okay, so it is API key. We pass it in here. Google API key, and then model, which equals in Gemini, I don't know, 2.5. Google Gemini API. What is our cheapest thing we can use? Is Gemini 3 Flash the cost sensitive? High volume, cost sensitive. Okay, I'm just gonna use this thing. I don't care. I don't care. What's the cost of this? How much does this cost? Google Gemini AI agents. Yeah, joke's on you. I'd rather just use LineGraph and do it myself. Is it inefficient? Yeah, but it's more scalable. Okay, how we're token maxing. API keys, pricing. 3.5. Ooh. Flashlight. Ooh, 0.25. Pretty nice. Anything else? Okay, so this is 0.5. It seems like flashlight is the cheapest. What is this? This is 2.5. Whoa, flashlight. Okay, give me 2.5 flashlight. Get it? Because it's a flashlight. Oh, it's so funny. Model equals model. And then the rest of the KW arcs. Okay, say the one attribute of the KW arcs get that must be passed in always. Is it alright if when creating the class which requires this attribute, I specify a value for it and then so pass in the KW arcs. This is just in case arcs doesn't contain a value or set attribute and I have to default to something else. Ah, I see. KW arcs to override your default. This doesn't really matter, I think. Void doing. Okay. Config which equals so KW arc replaces model, right? And then this is just ** config. Why is it? Why are you here? We're here. Model mappings. And then you pass in KW arcs as well. Okay, I think this is fine. I think it's fine. Defaults to using Gemini 2.5 flashlight if no model is specified. Okie dokie. And this is raises a value error and then raises Value error if there's no API. Okay. Model factory baseline application. Oh, we don't need this either. Conversation service, I want to implement that last. Okay, prompts. Save user preference. So invoke with schema, I believe, is a lang chain invoke with schema. Context overwrite. How does invoke with schema work in lang chain? I want my agent to return a certain schema, their response on a node. With structured output. With structured output, ... Wait a second. Turns a new runnable that wraps the model. Okay, so how does this work? Tool definition forces the model to call it, then parses the tool call args into your schema. Okay, instructs the model to output JSON matching a schema, then parses it. And this, you can control which method, the method param. Okay, sick. With structured output agent response. Okay. Oh, so then you invoke. Okay, so you do the structured output first, and then you invoke with the messages that you want the AI to see. Uh-huh. Okay. So what do we want to do here? So basically it makes it kind of like a tool call, or it's something like this, right? Then parses a tool call args into your schema. Oh, I see. So it invokes as if it's a tool, and then with LangGraph LLMs, they call tools by more or less just outputting some sort of like JSON file, right? I think that is correct. Okie dokie, okie dokie. So I don't have to. So there is no need to manually prompt the AI to follow a certain schema, right? Okay, okay, so this should be easy. I don't know why I'm procrastinating so much while working. So, you are an AI agent to help understand the user's preferences for a financial portfolio. Extract relevant information about the user's preferences from their messages. Update your output users' preferences from their messages. Potential things to look for in the user's preferences include risk tolerance. So investing purpose. What else? So what do I have in my horizon end? Okay. And user specific. It's called companies that you want to invest in or not invest in, right? Sector/company preferences and users specific company/sector preferences on others. Okie dokie. I don't want. See, can I just like disable okay, it's just broken. Shut up, slop pilot. What? Oh, 67 out of 200. Interesting. Can I like temporarily just like close it? I'm afraid I might dox myself when I do this. Luckily, that didn't dox me somehow. I'm very afraid I might dox myself when trying to close tab complete. Oh, oy, that's unfortunate. I guess I'll just simply live with tab complete then. So you are an AI agent looking to get the preferences of the user constructing a financial portfolio. So here we pass in the preferences that have been extracted so far, and then ask for any more preferences from the user, or maybe like repeat what it already sees just to with the user. And then here is just one last confirmation internally that user is done. This should only return true when the user explicitly says that they are done with providing preferences. Okie dokie. So, okay, I have a file prompts.py. I want to pass in the response of the AI agent, the output of the AI in a previous node into the prompt of the AI. A later node as kind of a system, as part of a system prompt. How can I do this? Can I just indicate there is a field, a prompt to be filled out at runtime? Okay, so you can in fact just use that. Okay. You are looking to ask the user for any more potential preferences they may have, and also confirm with the user that your current understanding of their preferences is in fact correct. Currently, your you think the user has the following preferences, and then preferences ask the user for any potential so how would this work? Would it be at like, oh no, it should be fine because the user only sees the respond to user prompt for any potential preferences that may have been missed. Potential preferences we're done providing preferences and all information is correct. Okay. You are an AI agent looking to get the preferences of a user building a financial portfolio. So you have asked the user for preferences. Does the user's does it appear that the user is then providing their preferences? Return true if the user I think this is fine. I think it's alright. Okay, there are my prompts. Response schema. Yeah, I want to keep everything as some sort of a dictionary or JSON object. So that's okay. User preferences state other Wait. Does the AI model see the doc strings of the Pydantic objects that are being passed them when they have to generate, what is it even called? With structured output. Generate with structured output. The field description. Okay. Description, when LangChain converts this into a tool. Alright. Oh, I see. Multiple structured output. After the description on each property, a model can only pay attention to these closely. Okay. Inline hints for what to look for. Description. So now field. Yeah, typed diff and field description equals the users, so we can just get rid of all of this, right? Ask for data object for representation of the AI agent's understanding of the user's preferences. Equals field description, the message from the LLM. Data object for representing the response from the LLM to the user is complete bool. Well, what if you just want LLM to return a simple Boolean? I feel like it's definitely overkill. Okay, I guess that works as well. Sure. With structured output bool directly. Some providers, but it is less reliable. Ay. Class LLM finished extracting preferences schema or state. I think like, well, what am I doing now? State base model representing the state data object for representing the user's preferences, and then is complete. Bool is going to be LLM finished extracting state. Wait, I feel like this is so extra though. I can just make this bool. None equals 1. User preference, we definitely need it. For the messages, this is the messages so far. So then we return the LLM's response, right? Response string. Right? I think that's how it works, and then we just extract the messages from here, shove it into here. Okay, I think that works. So, what's next? Now it's time to actually build a line graph. Okay, so this is the fun part. I want to refer to my past code just so I can make sure that I know what I'm doing. I sure hope VS Code doesn't dox me here. Doesn't appear to be doxing me. Haha. Okie dokie, okie dokie. You know what? I'm just gonna have this open in a separate tab because I just don't want too many things on the same screen. So you're just gonna have to deal with it. That's right. That's what you get for having for not having a large viewer base. Haha. Haha. The benefits of having 0 viewers. Crazy. Epic. Wowie. Mm-hmm. Mm-hmm. Yep, yep, yep. Yep, yep, yep. Okay, agent graph. So this thing's going to be pretty much the same thing. I just need to make sure I see what's going on. So we had an input queue here. Well, that's so interesting. Oh no, that's so that we can communicate with the memory stuff, right? In this case, how much does memory latency matter? I guess the lower latency the better still. But do we really need long-term memory in this case? I think with this project, just short-term memory is probably good enough. We don't need long-term memory, so we could just use a check pointer, right? Okay. Build graph check pointer equals check pointer, I reckon. Self.graph equals underscore or self.underscore build graph. And then build graph, what does this return? So what does langgraph.compile return? Chain runnable. Oh, that is compiled state graph. Runnable graph. Practice state graph, while compiled state graph is the thing that you actually run. Langgraph compiled state graph. Langgraph graph state. Okie dokie. From langgraph.graph.state import compiled state graph, right? I want to make sure I don't get this import wrong. That would be really awkward. Wouldn't it? Where can I even see the import? I'm just gonna ask ChatGPT. I don't want to look it up. It's a lot of work. How to import this using my langgraph graph state compiled state graph. Okay. Okay. Just need a runnable. What? Okay, sure. Langchain core.runnables import runnable. I don't really like those docs. I don't know, it just doesn't really feel super clean to me. But what do I know? Okay, let's just see. Return graph.compile, return graph.compile. Check pointer equals check pointer. Right? I think that's how you do it. Yeah, equals memory check pointer. Wait, hold on. Memory check pointer equals from lang chain, lang graph lang chain, lang graph dot checkpoint dot memory import in memory saver. Why is it not green? What? That's annoying. I want it to be green. And then we also need the LLM factory in here, right? From conversation agent dot agent import prompts. It's okay. Conversation agent dot model factory import model factory. Why is okay? Seeing why is it not green? Oh, it's called LLM factory. Boom. See, I think this is because we don't have LangChain installed on this. Why did I make a new environment? That's so stupid. Could have just used the old environment. Check pointer equals check pointer. And then, so do we need self.model? Oh yeah. LLM factory, or actually self.model, which equals Gemini. I'm just gonna default it to Gemini. We do the future. This defaults to Gemini. And then we also need LLM, right? Self.LLM. Okay, so in the future, maybe we need multiple instances. So we need one for like each different kind of model. So for example, one for one for extracting the preferences, one for getting responding to the user, and also one for checking if we're done. But in this case, we can just use one, right? What to do in the future, it might be to have multiple instead of just one. But I really don't feel like training more to finding more LLMs. It's annoying. Equals LLM factory dot create model Gemini. Okay. Dot build graph. So why do we need this in here? We don't need this. We don't need check pointer in the actual attributes. It's already built into the graph. Add node, self-record preferences, generate response, check is done. Generate response. Okay, we go, what? Graph dot add edge. Start. And then from line graph state, start, end. check is done. So no, we always go to the end there. Add edge I to generate response, right? Okay, then in that case, do we want generate response to constantly invoke some sort of tool for conversing with the user? Is that a good idea? So if we do check is done, and then the LLM decides that it's not done, then it calls some sort of tool, and then we return to record preferences or whatever. Or no, in that case we pass the user's or the AI's response, and then we go back to record preferences. Oh, that is a way to do it. That is for sure a way to do it. Is that the best way? I don't know. Is there a best way to do it? Probably there is. Ay, 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 ay. Okay, now what do we do? What do we do? Kind of just vibe. Oh well. Man, I'm bored. I wish I could get employed to be less bored. That would be great. What do we do? Okay, back to work. What was I doing? That didn't feel like a very complete break. Just kind of sitting there, bored out of my mind, waiting for it to be over. Breaks aren't that fun. Breaks are kind of stressful, low-key. I don't like breaks. Do you like breaking breaks? I love it when a break breaks. Okay. So I want to... So this is the thing that Copilot suggested me with their autocomplete, right? I was thinking that I just continuously invoke the graph every time, and until the graph says complete, we do stuff. But it seems like Copilot wants us to continuously stay within the graph, and in that case, architecture is a bit different. Actually, it is a bit different actually. So we'll see. So, working on a conversation agent for getting the user's preferences for financial portfolios. So I was thinking of two potential ways of implementing the AI agent. The goal of this agent is just to extract the user's preferences and pass it on to the research agent for the actual studying of the market. So the first option is to record preferences. What am I talking about? Who am I talking to? I don't know. It's the voices in my head. They're scaring me. The first option is to remain in the AI agent graph. So I am using LangGraph. This would involve 3 nodes. One for recording preferences, one for generating a response to the user, confirming their preferences and asking for more, and a node for checking that the user is done, or in their the AI agent has successfully extracted all preferences from the user. Okay. What do we do now? So in this option, we will in this option, so long as the final node of checking whether or not the AI agent has a full understanding the user's preferences is not considered complete, or not considered I guess complete is the right word. We'll loop back to the start of the graph, ask for user preferences, and check their record preferences and check again. This would likely involve a tool call for sending the AI's response to the front end and obtaining is not the right word. It just kind of hangs there until the user responds, right? Okay. The second option would be invoking the entire graph once every turn in a conversation. This conversation persists until the graph returns true. In this case, in every invocation of the is that even the right way to use it? Invocation. I am so good at English. Holy. #1 English. In every invocation of the graph, each node only executes once. So, which one do you think is the better implementation and why? Keep your justification limited to 6 sentences. Yeah. And then which one is consider scalability and readability, and maintainability. The code go wild. You know, I should really start reading the book, Designing Data-Intensive Applications, I believe. I feel like it would introduce me a lot deeper to the idea of how to maintain code and scale code and everything. I don't know. Okay, it says option 2 is a better fit. Per invocation with the checkpoint of persisting state across turns. Fresh graph invocation message the framework's natural request response model. Fighting it, option 1 requires a single graph Yep. Reads more cleanly. Yeah, so I'm kind of just better than Copilot at programming. Like, why am I so good at programming, huh? Am I just #1 AI engineer? Keeps need to knows to do one thing. Thank you, Claude, for agreeing with me, because I know I am objectively right. So thank you for reassuring me that I am right, because I'm always right, huh? That's right. Oh, I mean that's left, huh? Got him. God, I hate myself. Anyways, let's get to work. What do we need to do here? So we just need to clean this up. Check is done. We're not looping the generate response. Get out. Okay, look at how clean this code is. It's beautiful, isn't it? Now, return graph.compile. Oh, graph equals builder. Oh, wait. This is supposed to be builder. Oh, whoa. This is not good. So, is it here? States. Conversation state. From states, why is states being imported like this? States.com. I don't mind that. State graph, states.conversation state. Wait a second. You are builder. Builder, all of this stuff. Graph equals builder.compile. Graph equals builder.compile, and then return graph. And then invoke. So in this case, what would invoke do? It would just go through the graph, right? And then would this just be self.graph.invoke conversation input? Oh, wait. Okay. So we need to wrap the conversation input into a builder state, right? Or into one of these states, into a conversation state? What the frick? Oh wait, no. I think I understand. So I don't think I have a solid understanding of how invoke and stuff are meant to work in LangGraph, which means I need to research it, right? Yes, I should research it. Wow, I love water. So, what are you meant to input into the invoke method for the LangGraph graph? How does this change if you have sort of memory checkpointer attached to the graph? Without a checkpointer, it takes just input to a graph state, so there's no persistence. Each call is fresh, isolated run. The graph starts from start with everything that you pass in. Okay. Config. Yeah, we don't need a config right now. To compile your graph with checkpointer, you must pass a config. What? What the freaky deaky wiki? Okay, let us look at how I did it in the past. So if we go to a invoke, so we have to pass in the config, right? Man, LangGraph is kind of confusing, to be honest. Ah. One required argument, input match to your graph state, schema, isolated run, graph starts from start. Okie dokie. Thread ID and configurable. Okay. So in that case, we need to look at conversation input. And we need to say, okay, so this thing needs to have a config. So we just need thread ID. Yeah, so it has to have thread ID. I'm just going to call this thread ID instead. Thread ID. Set configurable, that's how the checkpointer knows which conversation to run /save. Checkpointer is allowed stuff to persist. When checkpointer is configured, you should pass thread ID into the config. Oh, so it automatically loads everything else, so you don't have to manually pass it. Which I'm looking at the code from my past project on this using AI stuff, and I just manually passed in everything. But that's also because I wanted the metadata and stuff. Which, I mean, to be fair, is fine. But it already just... I assume it just takes the state from however it saved it, right? So in this case, we saved it into memory. And we're just loading it from memory, right? Because it's just saved into cache. And then the checkpointer just looks at cache and it's like, okay, yes, we have this thread that is related to this object, and then it loads the state from the memory. Yes, that definitely makes sense. I don't know how much of that you guys understand, but you know what? 0 people understanding, or 0 people of 0 people understanding anything, that's 100%. 0 divided by 0 equals 1. I'm pretty sure that's how it works. I'm starting to realize that I might just suck at math. Thread ID is mandatory. Graph reload stuff. You need to pass new message update, not the full history. Also be none when you resume. After an interrupt. Thread ID to continue a conversation. So in this case, we just pass in config, right? So we just pass in that thing. Okay. Okay. So in this case, we go self.conversation model.invoke this thing. .invoke. Oh wait, it should be event, right? Wait, what is my data type for event? It's user conversation input based event, conversation ID. Yeah, so this should be thread ID, or conversation ID works as a proxy for thread ID. You know, I kind of like conversation ID more. But the problem is we're working with LangGraph, and LangGraph might not like that. So I might just explode. The code might just explode. Conversation model.invoke, and then we just pass an event, right? Because I believe event is of type user conversation input event, and then we take in user conversation input event into the thingy thing. Where's the thingy thing? Did I lose my thing? Oh, I found the thingy thing. Why am I so good? Conversation input, and then we invoke with this is nothing, and then config equals thread ID, and then we just go conversation input dot conversation ID, and then we don't need anything else in the config, right? I believe so. So let's say I invoke my graph with the following. Graph dot invoke this thing, config equals thread ID, and thread ID. Does this just load up the state from the thread ID? No, it's doing medium. I really want to implement the rest, but I don't think I'll be able to do it. Or nested under configurable. Oh, I see. Configurable. config thread ID conversation thread ID. Yay. Merges your input into that state since empty. No reducers fire. This is no opt update, so we don't change anything. One graph from start. While loads and it does nothing. Graph still executes. Starting on the entry point node using your entry node depends on messages. It will run whatever was persisted, but you don't have any. Oh yeah, you're right. I forgot about actually having the user's messages. So in this case, we need to actually get the user's messages. User prompt stir. Is it messages? What did I even call it? User prompt. Conversation input user prompt. And then we need to wait. Where's my states? Dude, why did I make my doc so confusing, huh? I literally said to make it. It's okay. We're experimenting. We're experimenting with code architecture. User ID. Conversation ID. We don't need user ID. We need messages. Messages. So we add on. It's a list of what? List of base chat message. So user preferences. Okay. Let's look at my last code. LLM input to LangChain events. Okay, so human message, yep. Okay, where is it? User prompt. Where did it go? Whoa. So user message, which equals human message content equals dot user prompt. And then from LangChain core schema base chat model. Do we need base chat model? I don't know. This is not even right. You're just stupid. Massages. Import human message. And we add messages, user message, right? Yeah. So let's say now my messages is meant to be a list of base messages from LangChain. If I have the input as the dict messages user message, does this automatically append user messages to the messages attribute of the state? I assume so, right? Or it depends on how you define the state. Or else it can sometimes just completely override it, such that add messages reducer, yeah. You need the add messages reducer. Okay. Messages annotated list. Base chat. Is it base chat message? I need to check this. Let me check my pasting. Wait. I think it might be called LangChain base chat message. Oh, wait, no, it's what? Base? No, it's called base message. Stupid. So do we see implementations of this? Yeah, human message, AI message. Okay. I'm just simply better than Claude coding as well. And add message. Okie dokie. From typing and annotated. From LangChain core.messages import base message. From lang graph.graph import add message. Okay, I think we're good. I believe we are good. Okay, now everything, now that does its stuff. So we do graph.invoke and then response, which equals this, right? Okay. Oh, I thought this was like an ETF. I want to set a cooler profile picture, but oh well. Response and then output, conversation output. What are we meant to have in this conversation? Oh, it doesn't have anything. Okay, we might need to pass user preferences out in conversation output, but we'll see. Conversation output, user preferences equals response user preferences, and then everything else I can't think of anything that I need to return right now. So we're just going to keep it like this, user preferences, and then this is just going to have user preferences. Okie dokie. Something's filled out for conversation agent in terms logic. Darn, I wanted to get more done. But it is what it is. It's 10. It's 10. You know what, gamers? You know what 10 is? It's bedtime for you nerds. Goodbye.